So I want to talk to you for a moment about an epiphany a lot of students have, and unfortunately it's one of those epiphanies you only get when you grind through a lot of buffer problems. See, buffer problems are basically the same problem being solved from a whole bunch of different angles. So let's say we work with an acidic buffer. We have the reaction HA goes back and forth, H plus and A minus. And now if I ask you what's the pH, what does it take to do this, every single time you're going to start with your ice table. So you've got some starting concentration of HA, some concentration of H plus, some concentration of A minus, your initial change in your equilibrium. And always we're going to assume we don't have any H plus, the change is positive, and the change is going to be positive for our conjugate base and negative for our conjugate acid. So for every single buffer problem, 5 points of this ice table are always filled in for you. The question is whether or not we start with, or how much strong acid we start with, and also how much conjugate base we start with. So we'll get Y minus X and Z plus X. Now, with any weak acid, we have some dissociation constant, Ka. This is related to our Q, and our Q is always the concentration of the conjugate base, acid, all over parent acid. So our Ka is going to equal these values which we get from the last row of the ice table. So it's going to be X for the H plus, Z plus X for the conjugate base, and Y minus X for the parent acid. This is essentially how every problem is solved. The only question is what variables are you given, what variables aren't you given, and how do you solve for them? So the hardest one to solve for is the H plus. But you've got 4 variables here. You've got X, Ka, Z, and Y. So Z is the constant starting concentration of your conjugate base, Y is the starting concentration of your parent acid, X is your concentration of H plus, and K is whatever your equilibrium constant is. So what you need to look at whenever you approach a buffer problem is to ask yourself, what am I given and how does this information relate to these 4 variables? Because you can't solve this relationship unless you've got 3 of the 4 variables. So when it comes to X, X is our concentration of H plus, but we can relate our concentration of H plus to pH. And we can also relate pH to POH if we're given it, POH, or even OH minus. When it comes to Y and Z, we can relate these to dilutions. Maybe you're given a certain amount of material and asked to water it down. So we can get Y and Z from dilution information. So this will be your M1 V1 equals M2 V2 relationships. Or we can get this simply from making the solution. So this will be our molarity equals moles over volume relationship. Same thing's true over here. It may be related to molarity, moles over volume. But essentially, to solve for any of the visiting variables, you have to have the other 3. So it's just a matter of figuring out how you're being given the other 3 variables. If you're given a pH or even a POH, that can be converted to H plus, so now you solved X. If you're given starting concentrations but not the Ka, well, you just plug these 3 into this equation, you'll get Ka. Let's say you're being asked for the concentration of the parent acid. Why? Well, you got to be given these other variables. So odds are you'll be given the pH to give you X, you'll be given Ka, and maybe you'll be given the starting concentration of the conjugate base. It all depends. But really, when you look at these problems, recognize that there's the heart and soul of the problem, and then there are periphery problems. And periphery problems are things that you're using to get the information you need to solve the buffer problem. At the end of the day, this is the only equation we're actually solving for with buffers. There's 1 variable in here that is not known, and 3 of these are specified, so we've got to solve for it. We can be given HA and H minus starting concentrations by dilutions. We can be given them by diluting some known mass down to a volume. We could be asked, well, what mass does it take? Well, that's easy. You just solve for the concentration, take your volume, and figure out how many moles you need. So try not to overcomplicate these problems when you look at them. At the heart and soul of every buffer problem is this equation. So solve for these variables, and then do whatever you're being asked to find to get the rest of the information.